Take a document the AI has never seen. Your own notes, a contract, a company handbook. Ask it a question about the contents. Early on, you would often get a confident, fluent answer that was simply made up because the model had nowhere to actually look. On its own, a language model draws from only two things: the memory baked in during training and whatever you typed into the prompt. Your private file is in neither place, so it guesses. The fix has a name, and it quietly powers a huge slice of the AI you already use. It is called RAG, short for Retrieval-Augmented Generation, and the idea in one line is to look it up first, then answer from what you found. By the end of this, you will know what RAG is, how the machinery works step by step, how it compares to the alternatives, and where it still breaks. Here is the plainest definition. RAG means you retrieve the relevant text from some knowledge source, paste it into the model's prompt as context, and let the model write an answer grounded in that real text, instead of only from its trained-in memory. Put another way, the model references an authoritative knowledge base outside its training data before it responds. The name and the method come from a single paper, in 2020, by Lewis and colleagues, and the three words are the whole pipeline. Retrieve, find the relevant text. Augment, add it to the prompt. Generate, write the answer from it. The rest of this video is really just those three stages, slowed down and made literal. So hold onto those three words. Retrieve, augment, generate. They are the spine of everything that follows. Now the deepest idea in the topic. That paper framed it as combining two kinds of memory. The first is parametric memory, the knowledge pressed into the model's weights during training. Think of it as a sealed brain. It is finite, it froze at a training cutoff, it is blurry on specifics, and crucially, it cannot tell you which page a fact came from. The second is non-parametric memory, an external, searchable index of documents you can query at the moment you ask. Think of it as an open library shelf you can add to, swap, or update without ever retraining the model. RAG simply lets the model answer from what it looks up, not only from what it memorized. A plainer handle for the same split, memorizing versus looking it up. That distinction carries the whole idea. The original paper reported the headline result directly. RAG produced more specific, more diverse, and more factual language than a comparable model relying on trained-in memory alone. More factual answers, with sources you can check, because the system knows exactly which passages it pulled, so the answer can carry citations back to the source. And remember the felt problem we opened with. A model alone only has its training memory, so your private notes and anything recent are unreachable. RAG hands it a live, searchable memory. That also makes updating knowledge easy. Retraining a model on new facts is slow and expensive, and must be redone every time the facts change. With RAG, you embed the new document, drop it in the index, done, and the weights never moved. And it builds trust. A confidently wrong answer is the most dangerous kind because you have no reason to doubt it. Grounding lets a person check the exact passage the answer used, which matters most for a doctor over a medical handbook, a lawyer over a contract, a support agent over a policy document. Two tools show the shape perfectly. The first is NotebookLM. You upload your own sources, documents, web pages, even audio, and it answers strictly from those sources, with inline citations linking to the exact passage. Grounded in your documents, not the whole internet. The second is Perplexity. Same machinery, different knowledge source. Every query triggers a fresh retrieval over the live web, the snippets are fed to the model, and the answer ships with numbered citations you click to verify. So one retrieves over your private files, the other over the world. Same RAG shape, the knowledge source is just the variable, and these are only the famous faces. The same pattern sits behind nearly everything labeled chat with your data. Support bots over a company's docs, research assistants over a pile of papers, internal question answering over a knowledge base. Point a model at a body of trustworthy text and let people ask in plain language. Before we open the engine, one property that makes the whole thing work. RAG does not find text by matching keywords, it matches by meaning. So a question phrased one way can find a passage phrased a completely different way. Picture a subscription document. You ask, when does my plan renew? The document never uses the word renew. It says you are billed on the 22nd and that your access expires at the end of the cycle. Plain keyword search whiffs because there are no shared words. But these phrases mean nearly the same thing, and meaning is what RAG searches on. Because it matches meaning, not spelling, a question in one set of words can even surface an answer written in another, across different languages. The standard term is semantic search, sometimes called similarity search. Now, how could a machine search by meaning at all? RAG runs in two phases. The first happens once ahead of time and it is called indexing. Step 1 is chunking. You split your documents into smaller passages, a few sentences or a paragraph each. Why bother? Because size is a real knob in both directions. A whole book will not fit the model's context window, the limited space a prompt has. A chunk that is too big becomes a blurry average of many ideas, so it matches everything weakly and adds noise. A chunk too small loses the surrounding context the answer needs. So chunk size is a genuine trade-off, not a solved default, and a bad boundary can split one answer across two chunks so neither retrieves cleanly. The standard term is chunking. Step 2 is embedding, which gets its own beat next. Step 3 is to store the result in a vector database. Chunk, embed, store. That builds the searchable library once before anyone asks anything. Here is the move that makes searching by meaning possible. An embedding model takes each chunk of text and turns it into a vector. A vector is just a long list of numbers, but those numbers are coordinates. They place the chunk as a single point in a vast space of meaning. Imagine a cloud of points drifting in space. Each point is one chunk, and the rule that organizes the cloud is this. Chunks whose text means similar things land near each other, even when they share no words at all. That billing passage and the word renew end up as neighbors because they mean nearly the same thing despite spelling nothing alike. This space has thousands of dimensions, far more than we can draw, so picture 3 of them and trust the idea scales. Text becomes a place, and once meaning is a location, finding relevant text turns into a geometry problem. Which points sit nearest to each other? Now you need somewhere to keep all those points ready to search. That place is a vector database, sometimes called a vector index. It stores every chunk's vector, and alongside each one it keeps a thread back to the original text the chunk came from. That thread matters because it is how a citation gets drawn later. Notice what this is. The vector database is the non-parametric memory from earlier made literal, the open shelf. An external store you can add to, swap, or refresh without touching the model at all. The original paper called its version a dense vector index built over a slice of an encyclopedia. Today you will hear many product names for these stores, and they change often, so treat the specific tools as the swappable layer. The durable idea is the geometry underneath. A searchable cloud of meaning with a way home to every source. The library is built. Now a question arrives. Phase 2 runs every time someone asks a question. It is the retrieve, augment, generate loop. Start with retrieve. The question is run through the very same embedding model that processed the chunks. That is critical. The same model, so the question becomes a point in the very same meaning space as everything stored. Use a different space and nearness would mean nothing. The question lands in the cloud as a new point, and the database searches for the stored point sitting closest to it, returning the nearest handful, called the top K picture a soft radius around the question. The chunks it touches light up as the evidence, everything else dims away. Because this matches by meaning, the renew question lights up the billing passage, with no shared keyword between them. Nearness is relevance made geometric. One honest detail, so this does not sound like magic. With millions of points, comparing the question to everyone is far too slow. So real systems use approximate nearest neighbor search. Instead of scanning the whole cloud, it navigates cleverly, hopping straight into the question's neighborhood and checking only a tiny fraction of points. You find almost all of the true nearest neighbors, fast, not a guaranteed perfect set. Approximate, but close enough. Now the step the technique is named for, and the single most important correctness point here. Augment means you insert those retrieved chunks straight into the prompt, alongside the question. Roughly, the prompt now reads, using the following passages, answer the question, then the chunks. Watch what happened and what did not. Knowledge entered through the context window, the prompt, not through training. The model's weights did not change. Nothing was learned, nothing was memorized. This is the misreading to kill on sight. RAG does not train the model on your documents. It looks them up fresh every single time you ask. Then comes generate. The model writes its answer conditioned on those passages, so instead of reconstructing from blurry memory, it is anchored to real text in front of it. And citations fall out naturally because the system knows exactly which chunks it supplied. The whole loop in one breath. Chunk, embed, and store once. Then on every question, embed the question, find the nearest chunks, paste them in, and answer with citations. The model is a reasoning engine. The index is a swappable store of facts, and RAG is the wiring between them. Two comparisons people ask for most. First, RAG versus fine-tuning. They sound like rivals, but they do different jobs. Fine-tuning edits the weights to change how the model behaves. Its style, its format, a particular skill. It reshapes the brain, and it is the wrong, expensive tool for facts, because facts go stale and you would retrain every time they change. RAG leaves the weights alone and supplies facts at question time. The rule of thumb. Fine-tune to change how it answers. Use RAG to change what it knows. And they stack. Second, why not just paste all your documents into the prompt? Now that context windows are huge. The window is still finite, however large it gets. It is costly and slow, since you generally pay per unit of text and longer prompts take longer. And it can be worse, because burying the one relevant sentence inside thousands of pages can make the model lose track of it. RAG fetches only the relevant chunk, so it is cheaper, faster, and often more accurate. Big context and RAG are complements, not a replacement. A footnote on lineage. The original system used a particular retriever and generator over an encyclopedia. Today's RAG swaps those for an off-the-shelf embedding model and a chat model. Same shape, modern parts. Production systems also add more, like blending meaning search with keyword search and a re-ranking step. Real and a deeper story for another day. So what do you actually wire together and what does it cost? The minimal stack is 3 pieces. An embedding model, a vector store, and a model to generate the answer, glued by the Retrieve-Augment Generate loop. And here is something people do not expect. This can run entirely free and on your own machine. A small local embedding model, a local vector store, and a local model, all on a laptop, no subscription. Or you can use hosted pieces if you would rather not run it yourself. The pattern is identical at every scale. On cost and speed, be realistic. Every question now does a little extra work first, embedding the question and looking it up, though that is usually tiny next to generating the answer. And you re-embed documents when they change to keep the index current. One reminder on those citations. A citation proves where text was retrieved from. It does not prove the answer faithfully reflects it. Verifiable, not verified, so always check. Now the limits, which are what make this a real explainer instead of an advertisement. The biggest. RAG is only ever as good as its retrieval. Fetch the wrong or incomplete chunk and the model answers confidently from bad evidence, and now that answer is cited so it looks more trustworthy while still being wrong. Retrieval can miss where the right chunk never surfaces or misrank where a weak chunk crowds out the one you needed. The mantra, retrieval is the ceiling. Hand even a perfect model the wrong page and you get a confident wrong answer. Second, and say this carefully, RAG reduces hallucination, the tendency to make things up. It does not eliminate it. Passages can be on topic yet not enough to answer, documents can contradict, and the model can still misread good context. In one study, Even retrieval-augmented legal tools still hallucinated a meaningful fraction of the time. So the honest language is far fewer, sharply reduced, never eliminates, never a single dramatic percentage. Third, garbage in, garbage out. RAG inherits whatever is in the source. Stale or wrong documents produce stale or wrong answers, now dressed in citations. Grounded means grounded in whatever you gave it, not in truth. And freshness lives in the index, so RAG only knows recent things if you keep it current. Finally, retrieval is not reasoning. Supplying the right passage and getting the right answer are different events, and chunking itself is lossy. None of these are reasons to avoid RAG, just reasons to build it carefully and keep a human in the loop. Let us puncture 5 myths directly. 1. RAG means the AI learned my documents or I trained it on my data. No, the weights never change. It looks them up fresh every time from an external index. A librarian, not a memorizer. 2. RAG is just keyword search with extra steps. No, it is semantic search. It matches meaning so it finds the right passage even with no shared words like renew finding build. 3. RAG eliminates hallucination and makes the AI always right. No. It reduces, it does not eliminate, and bad retrieval produces a cited wrong answer. 4. With huge context windows, RAG is obsolete, just paste everything in. No, the window is finite, it is costly, and the answer can get lost in a giant prompt. Fetching only the relevant chunk is cheaper, faster, and often more accurate. 5. A citation means the answer is verified true. No, a citation shows where text came from, not that the answer reflects it. Verifiable, not verified. So step back. The durable idea underneath all of this is a clean separation. RAG draws a line between the model that reasons and the facts it reasons over. Knowledge stops being welded into the weights and becomes a swappable, updatable, attributable attachment. A fixed reasoning engine on one side, a live, searchable, citable memory on the other. The specific databases and embedding models will keep changing. That separation will not. And notice where this fits. Chat with your data, the document assistants, the answer engines. They are all this one pattern. RAG is also a foundational building block of agents, AI systems that take actions, because giving a model the ability to look something up is the very first of the tools that turn a text predictor into something that can act. So here is the whole thing in one line. A model on its own can only answer from what it memorized. RAG lets it look things up instead. From a memory you can search, update, and check. Memorizing and looking up are different skills, and the real discipline is making sure it looks up the right thing.